Section 7.3a is about elimination using addition. Elimination is an algebraic method of solving a system, so it's just like substitution in that regard. It's algebraic, except this time it involves eliminating one variable and solving for the other. So let's take a look at what elimination looks like. First, I want you to notice why substitution would not be a good choice here, because there is no coefficient that's a 1, and so isolating one of these letters would just be difficult. But I also want you to notice that the coefficient of the y's is a -5 and a +5. So watch what happens. I'm going to take these two equations. I'm going to put it with a plus sign in front and treat it just like an old-fashioned grade school addition problem. And I'm going to add the columns together. Well, 3x plus 2x is 5x. -5y plus 5y. Well, what's -5 plus 5? The answer is 0. So we cross those off. And the -16 plus 31 is +15. And look what happens. The y's are now eliminated. Now I can solve this easily. Divide by 5. And so x equals 3. Ta-da! Next thing I have to do, though, is figure out what the y is. So I'm going to take that and plug it back in. I don't care what equation you use. I'm going to use this one. So 2 times x, which is 3, I'll use the orange to maybe help you see it. 2 times 3 plus 5y equals 31. So this is really a 6, so I'm going to subtract 6. 5y equals 25, and divide by 5. So y equals 5. X and y, therefore my solution is 3, 5, which means this system has one solution. The two lines would cross in one place, and they cross right here. So notice what elimination is. You eliminate one variable by adding, and then you solve the other. Here I'm going to use elimination, so we will take these two equations and add them together. X and x is 2x. Negative y and y goes away. 14 and 20 is 34. Divide by 2. So x equals 17. I'd now take that 17 and plug it back into one of these. Let's go with the second one. So 17 plus y equals 20. Subtract 17, and you get y equals 3. So the ordered pair is 17, 3. There's nothing magical about eliminating the y. It just turns out that that's the letter that's been used in these two examples, but when you add them together, one of the variables should be eliminated. Here's another elimination problem, this time using different letters other than x and y. Doesn't matter. Solve it the same way. We're going to add 2a and a is 3a. -3b plus 3b is 0, and -11 plus 8 is -3. Continuing to solve this, you get a equals -1. And then we will plug that back into, again, I like the second equation. -1 plus 3b equals 8. So we'll add 1. 3b equals 9. So we get b equals 3. Now what order do you put these in? You put them in alphabetical order, so the ordered pair -1, 3 is my solution. Here's our last elimination example. Finally, we get one where the first letter will cancel. 2a plus -2a is 0. 4 plus -2 is really 4 minus 2, so that's 2b. And 30 plus -21, that's really 30 minus 21.5. Just to show you how that's going to work. 21.50, so 0, this becomes a 29, and we borrow. And then 8, so 8.50. Divide sides by 2. Well, if I divide 8 by 2, I get a 4, and if I divide 50 cents by 2, I get 25 cents. So B is 4.25. Now I got to take that and plug it, I like the top one. So 2a plus 4 times 4.25 equals 30. So we have to multiply 4 and 4.25. I'll go down here and do that. 4 times 5 is 20, carry the 2, that's an 8 plus 2 is 10. 16 and 17, so 17 even. So 2a plus 17 equals 30. Subtract 17 from both sides. So 2a equals, what's that, 13? And then divide both sides by 2. 12 divided by 2 would give me a 6. So 13 divided by 2, so that's a 1, and that's going to be a 0.5, so 6.5. Now your answer is not in the order in which they come, it's alphabetical. So 6.5 is the A, and 4.25 is the B.